Hi everyone, today I'm going to present about our system which is face mask detection system using image classification. Let me introduce our group members first. First one is Xiaxing Wang, second is me, Ashwin unlike YATHIPAN, and third is Chu Weilun. And here is table of content. We got 9 contents here. Let's see one by one. First one is project background. The use of face mask is a critical public health practice for reducing the transmission of airborne diseases in high-risk environments like hospital and clinics, yet ensuring consistent compliance remain a significant challenge because traditional manual monitoring is labor-intensive, resource heavy, and prone to human error. To address this, recent advancement in artificial intelligence and computer vision allow for the automation of mask detection through the image classification model that can learn visual patterns and categorize them in real time. This project proposes an automated face mask detection system developed using Google's Teachable Machine and mobile net architecture to provide a scalable, low-code solution that identifies mask compliance effectively without the need of human intervention. There are three objectives for our project. The first one is to design and develop an AI based face mask detection system using image classification techniques. Second one is to train a machine learning model that can accurately classify facial images in two classes, which is with mask and without mask. Third is to train a machine learning model that can accurately classify facial images into two classes, which is with mask and without mask. Now let's see our scope. The first thing in our scope is the system uses image classification only is limited to detecting. It can only detect face with mask and face without mask. And second is face detection is performed using the camera input or uploaded images. Third is the project does not perform identity recognition, detection of mask type or mask quality, multi-person detection in crowded environment. The fourth is model is trained developed using teachable machine with no advanced coding required.
Hi everyone, my name is Yasin. So I'm gonna to present the project significant. The first one is to enhance the public safety, automate monitoring of mass compliance, reducing reliance on manual checking. The second one is to improve the public health readiness, useful beyond COVID-19 for hospitals, clinics, and areas requiring hygiene control. The third one is to reduce human error. AI provides us consistent and accurate detection compared to manual observation. Next, cost-effective and scalable. Built with teachable machine, this solution can be easily deployed on a laptop, kiosk, or school project environment. And the last one, educational value. Students gain hands-on experience in image recognition, data preparation, model training, and real-world AI applications. All right, so for the project expected outcome, the first one is to develop an AI-based face mask detection system using image classification. The second one is to perform a real-time and image-based mask detection with reliable accuracy. And the last one is to enhance the understanding of machine learning workflow through a functional prototype. All right, so for the methodology, underlying technology, teachable machine framework, the mobile net algorithm, and the last one, mechanism transfer learning. So for the first one, teachable machine framework, the project utilized a web-based low-code tool that allows for rapid prototyping of machine learning models without extensive computational resources. For the mobile net algorithm, instead of building a network from scratch, the system employs MobileNet, a convolutional neural network, specifically optimized for speed and efficiency in web browser and mobile devices. And the last one for the mechanism, which is transfer learning. The model leverages a pre-trained version of MobileNet trained on the massive ImageNet dataset. By freezing the base layers, the system only needs to train the final classification here to distinguish between mask and no mask. So for the teachable machine implementation, data acquisition module, the dataset was constructed manually using the webcam capture feature. However, for the dataset composition, class 1, which is with mask, there are 100 images featuring surgical and cloth masks. However, for the class 2 without mask, there are also 100 images of team members with bare faces. For the data augmentation, to ensure readiness, images were captured at varying distance from the camera, different hair angles, and diverse lighting conditions. For the pre-processing, all images were automatically normalized and resized to 224 multiplied 224 pieces to ensure consistent input for the neural network. And the last one for the training configuration, hyperparameters equals is set to 15, which to is chosen to allow sufficient learning while preventing overfitting. For the batch size is set to 16. This is the to selected to optimize the training speed and memory usage in a browser environment. And the last one, learning rate, is set to 0.001, set to precisely control rate updates in response to estimate error. That's all from me. Thank you.
Now let's see about solution design. The first one is input, which is live video feed captured at 30 frame rate per second, and processing is using TensorFlow.js process the 224 by 224 resize frame, and the output is probability scored for each category displayed via a dynamic prediction bar. Alerts is green indicator for compliance, red for without mask if threshold is more than 85%. Now let's see about model testing and performance analysis. Learning curves. Accuracy reached 100% quickly while loss dropped to near zero instantly. Our confusion matrix, 15 by 15 samples of with mask correctly identified, 15 by 15 samples of without mask is correctly identified, total accuracy is 100%, and the justification, the high performance is due to clear visual distinctions between a mask face and a bare face, allowing the model to learn features rapidly. That's all from me, thank you.
Hi, my name is Chuilun. Now let's move on to our project testing scenarios. We wanted to see how our system perform in the real world, so we test it in 4 different situations. First, we look at the ideal scenario. This is when we have bright lighting and the person is standing close, about half a meter to a meter away. In this case, the accuracy is high. The system detects the face immediately with high confidence. Next, we tested low light condition like a dim door room. The result was still good. We noticed a tiny bit of fluctuation, but the system still correctly classified the image. Then we tested distance. When the subject moved more than 2 meters away, the accuracy drops to moderate. This is simply because the facial feature becomes smaller and harder for the camera to see clearly. Finally, we tested occlusion, such as putting a hand over the face. Here's the result were mixed. Sometimes, if a hand covers the mouth, the system gets confused and thinks the hand looks like a mask. Okay, the last one is conclusion. The face mask detection system demonstrates the potential of artificial intelligence in public health and safety management. Using Google Teachable Machine with the mobile net architecture and transfer learning, the system achieved 100% accuracy on the test dataset and operated in real time within a web browser. This project highlights the accessibility of modern AI tools for rapidly developing effective solutions to real-world health comprise challenges. Future improving includes expanding the dataset to detect improper mask usage and integrating the model with IoT devices such as Raspberry Pi to enable automated access control. This enhancement will transform the system into a scalable, real-world solution for smart city and public transport environments. Now we demo the tangible machine model. First, we have the 100 image sample for the with mask class, and we also have 100 image sample for the without mask class. For the training setting, we just keep it default, and the export is 50, backside is 16, and landing rate is 0.0001. Okay, for now, for our model, now I know where any mask, so the output is without mask 100%. So this is correct. Next, I will test. I wear three color of mask, which is deep blue, light blue, and white. Okay, the first one is deep blue. Okay, so the output is correct with mask 100%. The next is light blue. And with mask also the output is 100%. So this is correct. The last one is the white, so the output also with mask was 100%, so that is correct. That's if the system can be full. I will cover my mouse with my hand so to see if it's mistake it for a mask. So now I remove the mask and I cover the mouse with my hand. As you can see, the model is smart enough to tell the difference. Even though my face is covered, it does not detect it as a mask. It is correctly identified that a hand is not a face mask.